Okay, so I wanted to make some videos on complex analysis today because the Maths Society did a couple of one revision lecture on it today, and well, I felt like I didn't really understand what was going on, and so I wanted to make some videos on it. But first, I wanted to start with something easy, at least to get me warmed up, which is the reverse triangle inequality. And maybe you think that's like literally the most obvious thing, but it's used in some of the proofs for the what do you call it? The integral theorem. And the weird thing is, some of these theorems, like the pigeonhole principle, they're not hard, right? But then they have these weird names which like make them seem like they're difficult to prove or something like that. And then the pigeonhole principle, they prove it with functions, whereas it's more or less obvious, right? That it's true. That if you have like q boxes and q plus one things, and you put the things in the boxes, then one box will have more than one thing in it. And even though it's not clear how you prove it, it's like an obvious thing, so if you just take it as an axiom. I mean, or like it should somehow be true. But anyway, the thing we want to prove is the reverse triangle inequality. So, well, let's have a look at the normal triangle inequality, which just says if x plus y, so this is something. It doesn't matter what this is, but the triangle inequality gives us this. No, it doesn't. So this should be a. Okay, which way is it? Is it, well, this is bigger, right? So if you have sum of two things, right, then, well, the whole is, the whole is less than the sum of its parts or something like that. But that's a bit weird. But what it's saying is that there could be some sort of cancellation over here. But when you just look at the size of x and y by themselves, then this will be bigger. That's just such a sus explanation, but for most things, it's kind of obvious, right? If you have some arrow going like this, in fact, I think the way they explain it is like, so x can be a line like this, right? And y can be a line like this, and x plus y would be a line like this. And these absolute values just tell you the length, right? So you can clearly see that going from here to here, which is this, is going to be shorter than going from here to here, which is going x and then y, right? Which is this. So clearly this is shorter, right? Okay, so what does a reverse triangle inequality tell you? Well, so over here we did this is x, this is y, this is x plus y. So the reverse triangle inequality, what it does is, let me think. But anyway, let's first write it down. That's the thing. Is the reverse triangle inequality? Oh wait, I should put 2 bars around it just to make sure that we're doing vectors here, right? And what does a reverse triangle inequality say? Well, it says, so basically over here we say it's a less than or equal to, right? In the reverse triangle inequality, it's a greater than or equal to when you go on that side. So we have the x, and this could be a plus or a minus. It actually doesn't matter. So I think the way they write it is with the minus, but actually you can just put a plus as well if you want. And then this is okay. So why is this true, right? This is a pretty sus looking equation, but actually you can actually get this from here, right, via substitution. So first of all, what are you going to substitute? Well, first of all, you want x minus y. So what you're going to do is you want to substitute x with x minus y in like both of these parts, right? Because you want to get this equation out. So let's forget that we have this for a second. We'll forget this, and we'll just look at this, and we'll replace x with x minus y. There's no reason we can't do that, right? And if we do that, what do we get? On this side, x minus y plus y just gives us x, and this is less than or equal to. Now over here we have, well, we substitute x with x minus y, so this is x minus y, and we just leave y alone, so we get just y, like that. So it's still the triangle quality. Now we can just move this y over here, and we get minus the value of y, so less than or equal to. Okay, so now we've got this. So where does the absolute values come from is what you might ask next, because this is the same, right? These two are the same, which I just wrote the wrong way around. But well, this has absolute values in it, and the reason it has absolute values is because of the symmetry in this equation, right? I can switch the x and the y around, right, in both of these equations, and this would still hold. So this inequality actually holds for both this case and the case where, in this case as well, it still holds by symmetry. Because if I flip these around, I just get a minus sign, but the norm cancels out the minus sign, so it's still minus x minus y. So because both of these hold and forms a lower bound, we can just put an absolute value in, right? Because the absolute value would just give us a greater one of these two, and since both hold, the greater one also holds. So, and then so we're done. So we've proved it. We've proved this statement. Okay. So what does a picture look like then? The picture. Well, what we did is we replaced in this equation we've replaced this, we've crossed this out, and so I think what we need to do is we need to make y go the wrong way or something like that. So we have this equal x, and then this is minus y, right? And then what do we have? And then this, from the triangle inequality, it would give us, well, it would give us this, wouldn't it? No, it would give us this. So the triangle inequality would give us this from here, and then yeah, we'd have to rearrange it. I guess I don't know how to show it in a picture, but yeah, I hope this part makes sense. So thanks for watching.